Microsoft just released an AI that can solve problems worth billions of dollars in minutes, and it's called OptiMind. And if you're hearing that name and thinking, okay, cool, another AI model. But no, this one's actually different. It's not trying to be ChatGPT, it's not another chatbot or image generator. This thing is solving a very specific problem that's honestly been blocking real-world business decisions for decades. And if it works the way Microsoft says it does, we're talking about a pretty massive shift in how entire industries operate. Okay, so here's what's happening. Every single day, massive companies are trying to solve these incredibly complex problems. Like, imagine you're FedEx and you need to figure out the best way to route 10,000 trucks across the country while minimizing fuel costs, meeting delivery deadlines, and dealing with traffic and weather. Or you're running a factory and you need to schedule production across 50 machines, 15 products, and 100 workers without creating bottlenecks. These aren't guessing games. Companies use mathematical optimization solvers for this stuff. And these solvers are genuinely brilliant. They can process millions of variables and tell you the mathematically perfect answer. But here's the catch. The solver isn't actually the hard part. The hard part is getting your problem into a format the solver can understand. You can't just tell it, hey, I need to optimize my supply chain. You need to translate your messy real-world problem into precise mathematical language, something called a mixed integer linear program, and this translation process requires serious expertise. We're talking about people who've spent years studying operations research. It can take them days or weeks to convert one business problem into the right mathematical model. And if they mess it up, the solver gives you complete garbage. So you've got this ridiculous situation where companies have access to these incredibly powerful tools. But there's this brutal bottleneck right at the beginning. The hardest part isn't solving the problem. It's translating English into math. And that's been true for decades, until now. OptiMind is Microsoft's solution to this. You describe your optimization problem in normal language. Supply chain planning, workforce scheduling, resource allocation, whatever. The model reads it, figures out the structure, and gives you two things. First, a complete mathematical formulation. Second, actual working Python code that you can run immediately, not pseudocode, not an explanation. Actual executable code using Gurobi, which is one of the industry standard solvers. It defines all the variables, sets up the constraints, specifies what you're trying to optimize, runs the solver, and prints the answer. If this works as advertised, you just turned a multi-day expert-level job into something that takes minutes. Now let me tell you how they built this, because the approach is genuinely clever. OptiMind is a 20 billion parameter model. That's actually pretty small by today's standards. It uses this mixture of experts architecture, which basically means only about 3.6 billion parameters activate for any given problem. So it's got huge capacity, but the compute costs stay reasonable, and the context window is absolutely massive. 128,000 tokens. That's important because real optimization problems get complicated fast. Multiple stages, conditional constraints, weird edge cases. With that much context, the model can hold your entire problem description and think through it properly. And get this, it's released under the MIT license, completely open source. You can use it commercially, modify it, integrate it into your systems, whatever you want. Microsoft Research just dropped a specialized AI model for free and said do whatever you want with it. That's pretty rare. But the really smart part is how they trained it. Microsoft didn't just dump more data into a bigger model. They did something way more strategic. They started by breaking optimization problems into 53 specific categories. Traveling salesman problems, scheduling problems, network design, all these different types. Then they ran the base model on samples from each category and watched where it screwed up. And instead of just retraining, they brought in actual optimization experts, real people who do this for a living. These experts looked at the failures, figured out the patterns, and wrote specific hints for each problem class. Like for the traveling salesman problem, there's this thing called subtour elimination constraints. If you don't include them properly, the solver gives you routes that have disconnected loops, which is obviously useless. The experts wrote hints explaining exactly how to handle that. Then Microsoft used those hints to clean up the entire training dataset. They regenerated solutions using the hints, filtered out inconsistencies with majority voting, and ended up with much cleaner training data. And here's something crazy. They found that between 30 and 50% of public benchmarks in this field are just wrong. Missing information, ambiguous descriptions, incorrect answers. So they're not just building a better model. They're basically saying the entire way we've been evaluating these systems is flawed. When you actually use OptiMind, it's not just a one-shot thing. It's a multi-stage system. First, it figures out what type of problem you're asking about. Then it pulls up the relevant expert hints for that category. Then it works through the reasoning, builds the mathematical model, and generates the code. And if you want even better accuracy, it can generate multiple solutions, run them all, and pick the one that shows up most consistently. It's applying the same kind of verification logic that solvers use to check its own work. There's also this multi-turn correction mode, where it actually runs the code, sees if anything breaks, and fixes it. So if the solver throws an error, or the constraints don't work, the system revises the formulation and tries again. It's almost like having an expert who can debug their own work. The performance numbers are solid. Microsoft says OptiMind improves accuracy by about 10% over the base model and beats every other open source model under 32 billion parameters. On their cleaned benchmarks, it's competitive with way larger proprietary models. And remember, this is something you can run locally. You're not sending your sensitive business data to someone else's servers. Now, Microsoft is upfront about the limitations, which I actually respect. The model can still generate wrong formulations or code that doesn't work. It's specialized for operations research problems, so if you ask it random stuff, no guarantees. They recommend keeping a human in the loop for anything important and explicitly warn against using this for critical applications. Healthcare decisions, financial approvals, legal judgments, anything where you can't afford to just trust an automatic result. And they strongly suggest sandboxing any generated code before running it, which makes sense because this thing outputs code that actually executes and interacts with a solver. If you want to try it, it's on Hugging Face and Microsoft Azure AI Foundry. You can serve it using SGLang as an OpenAI-compatible endpoint, so it fits into existing workflows pretty easily. You need a Gurobi license because the generated code uses Gurobi Pi. So what does this actually mean for the real world? If OptiMind keeps improving, optimization stops being this expert-only thing and becomes accessible to way more people. Supply chain teams, logistics planners, operations managers, anyone who understands the business problem can describe what they need and get working models back. That's a genuinely big shift. We're not just talking about AI that writes text or makes images. This is AI that generates mathematically rigorous decisions that industries can actually use, and that could change a lot about how businesses operate. All right, that's the breakdown. If you want more deep dives like this, hit subscribe, drop a like, and I'll see you in the next one.